Hello, everybody, and welcome to this talk from Chris Griggs from the US Army, who's going to give us a presentation on targeted opportunities for graphene-enhanced water infrastructure and structural assets. As always, please leave your questions in the sidebar, and I'll come back at the end of the presentation and we'll take those live. Over to you, Chris.
Hello, everyone, and thank you, Chris. My name is Chris Griggs, and I'm speaking on behalf of U.S. Army ERDC as it pertains to graphene. I have a couple of contributors, Dr. Jesse Doyle and Monet, who have contributed to this in terms of some of the other materials we're working with, specifically asphalt and cement. My background's in water and environmental, so they'll be heavy on that. We're pretty mature in that area, but overall, we're looking at targeted opportunities for graphene-enhanced water infrastructure and structural assets. So the outline would basically, ERDC, who are we? We're the U.S. Army Engineer Research and Development Center, who we are, what we do. And then I want to talk about the targeted opportunities, the fit-for-purpose applications for graphene. We've been active in graphene for a number of years now. We have got it from all the vendors that we can get it from, and we've explored the space in terms of like, where do we think it's a game changer? And so the three targeted opportunities that I want to highlight today are novel water treatment. That's something that, my research group is heavily involved in right now. And then the nanomodification of asphalt, specifically the binder. So that's one of the things that we're showing the really promising results. And then kind of hot off the press and new to what we're doing is graphene and cementitious materials. And we're seeing some strength gains there as well that are real. And so what we're trying to think about when we look at these different application spaces, you can see graphene at the center. There's quite a bit of opportunity here, right? So no shortage of problems, no shortage of potential applications, but we do have finite resources. So based on the funding and then, discovery-driven research where we see the data going, we take the graphene and its, form as a receive as a powder, and we turn it into a composite or material that has the functionality that we desire. So a little bit about us as U.S. Army Engineer and Research Development Center. We have 7 labs at 4 locations. So I'm based at the headquarters, which is in Vicksburg, Mississippi. We have a coastal and hydraulics laboratory. I'm with the environmental laboratory. We have a geotechnical and structures laboratory, and we have information technology laboratory. So a lot of capability right here in Vicksburg, Mississippi, but we also have 3 other locations. Our construction engineering research facility, which is in Champaign, Illinois. We have a cold regions research, which is based a lot of technologies that we do just in very cold environments. And then we have a geospatial research laboratory, which is located in Alexandria, Virginia. So wide variety of disciplines, engineers and scientists, lots of capabilities. So we're kind of a one-stop shop for a lot of different things that people are interested in. So we are honest brokers. We work for the government. So what we do is for a living is we solve problems. We're not selling anything. We're just trying to provide solutions to challenging problems. So, but today for the purpose of this talk, the data that I'll be showing you is from the environmental laboratory, which I'm associated with, and then my partners and colleagues in the geotechnical and structures laboratory. We don't do it alone. We have a lot of broad research areas, and we do have some active collaborations with joint funding. In the areas of asphalt, that's something that we're very interested in working with both private sector and academia, concrete, water filtration, nanocomposites, particularly as it pertains to the polymer interface with graphene, advanced materials by design and self-sensing infrastructure. That's something that we're getting into. And now we've just started a new effort with additive manufacturing and 3D printing. Our current partners that we're working with are University of Mississippi regionally, University of Southern Mississippi, their polymer science and engineering department, Jackson State University also regionally, which is their computational chemistry department to look at some theoretical predictions. And then, of course, Rice University, which is well known for graphene, working with Professor James Stewart, his world-class research group there. So we're happy to be working with all of them. What ERDC does and kind of where we fit into this, between the private sector and academia, we bridge the gap. We can lift heavier than academia. We're not just confined to the lab or the beaker. Or theoretical, we actually make things happen, and we do a lot of prototyping, and we scale things up. So that tech transfer is something we're proud of. So we can't lift as heavy and do as much as the private sector in terms of how much, like how many units are you going to buy, that type of thing. We're not driven by market drivers. We're just answering questions and delivering solutions. And so